All right, hello. This is the notes for your target 2A and target 2B. So these targets are slightly different. Most of the other targets will just be the one target, but for this one you kind of have to do both at the same time. So we are going to do target 2A and target 2B. This target is also different because these targets are also different because they are very long. So we are going to kind of chunk these notes into 3 sections. So this is kind of the first section of the 3 notes for this module. So you'll need to do this first one, then take the quiz, the next one, take the quiz, the third one, take the quiz, and then you'll be ready for the assessment. So that's kind of going to be the pattern for how this goes. So make sure that you're taking notes. I would take the notes all on 1 page or all on 2 pages. So don't do them on 3 separate pages. Just put them all together so that you have everything in one spot. I would just make sure that you section it out. So for this one, I would make sure that you know that it's just the intro. So if I was you, I'd write target 2A and 2B notes at the very top of your page, and then I would write kind of in bigger letters that this is just the intro for target 2A and target 2B. With that, for target 2A, this is what I expect that you should be able to do by the end of this. You need to be able to construct an explanation based on evidence that explains how organisms break down molecules and rearrange them to make other essential molecules according to the law of conservation of matter. And then for target 2B, you will need to use a model to illustrate the release of energy in bonds, including the inputs and outputs of cellular respiration. So with that, we are going to get started. This, like I said, is just kind of an intro. You have to understand this background information. You have to understand this vocab if you are going to be successful in these targets, which is why we are focusing an entire PowerPoint on it, because it's very important to understand these things first before moving ahead. So this is some terms that you will need to know for these 2 targets. The first one is an atom. So an atom is the smallest unit of an element, which isn't as helpful if you don't know what an element is. So an element are things like, atoms are things like oxygen, copper, carbon. Those are all atoms. I kind of think of them as like individual Legos. So we have an individual blue Lego that might represent an oxygen atom. We have an individual red Lego that might represent a copper atom. Individual yellow Lego that might represent a carbon atom. So like these Legos have different colors, right? Just like atoms are different, but an individual Lego is just a unit of something. So an individual atom could be oxygen, could be copper, could be carbon. An element is going to be a substance or a thing made up of the same type of atom. So for example, we can have oxygen as our element. That's just going to be a bunch of oxygen molecules. So a bunch of blue Legos together. We could have copper as an element, just a bunch of red Legos together. We could have nitrogen as an element. Let's say nitrogen is green. We have a bunch of green Legos together. So the biggest difference between an atom and an element is an atom is only one of those things. So an atom is one oxygen. An element can be multiple. So an element could be 1,000 oxygens. It could be 2 oxygens. These words are a little bit confusing. I would write down the definitions, and I would maybe write down the example that I gave you, that an atom is like one Lego, an element is like multiple Legos of the same color. Next we have a bond. So this is when atoms stick together. So when we have blue Legos, or 2 blue Legos sticking together, a blue and a yellow Lego sticking together, that would be like they're bonded together. When these elements bond together, or when these atoms bond together, we get molecules. So 2 or more atoms bonded together. So you can have an oxygen molecule, which is 2 oxygen atoms bonded together. So if oxygen is a blue Lego, it's like having 2 blue Legos bonded together. You can have very complex molecules, like we see this Lego structure here. It's a bunch of green ones, it's a bunch of yellow ones, but there are a ton of them. So a ton of green Legos, a ton of yellow Legos. When I think of molecules, my best example that I can give you is like Lego structures. You can have structures that are more than just green and yellow. Obviously, there's a bunch of different Lego structures that people have made. I was not into Legos as a kid, but if you were into Legos as a kid, I'm sure you built different Lego structures. Those are kind of like molecules. Those individual atoms are bonded together to create something larger. So this is the last page of terms that you need to know. So the first one is a reaction. So we're going to be talking about this a lot. So it's important that we understand what a reaction is. So specifically when we're talking about like a chemical reaction. So a chemical reaction is when the arrangement of atoms form a new chemical compound. So we start with some molecules on one side of our reaction, and then as we go through our reaction, those molecules will those atoms will break apart and they will rearrange to form other things. So it'd be like if you had a pile of Legos and you created something and then you're like, I don't like it, I'm going to change it to something else. You break it all down and you create something new. You still have the same amount of Legos, you still have the same Legos, you just made one thing originally and now you're breaking it down and changing it to something else. That is kind of what is happening in a chemical reaction. You have the inputs of the reaction. So this is the molecules that are going into the reaction. So let's say someone gives you a sculpture of a dinosaur, a Lego sculpture of a dinosaur, and you're like, I don't want a Lego sculpture of a dinosaur, I want a Lego Batman. So you break down this Lego structure of the dinosaur and you rearrange it so that it makes the Lego Batman. You have to use the same Legos, you have to use all of the Legos, but you are just changing the structure of those Legos to be something else. The outputs is going to be what you end up with. So like I said, if the dinosaur is the inputs, someone gave you a Lego dinosaur, the output would be the Batman that you just changed those Legos into. So inputs are what's going into the reaction, what you're starting with. Outputs is what you end with. So whatever it ends up being at the end, those are your outputs. So I would write all of these terms down. If you have not been writing them down, I would go back and write them down. Pause this video, go back so that you can get these down, because like I said, this is kind of your foundational knowledge that you will need to be successful going forward. Here's another example of a reaction for you. So when I think of reaction, sometimes I think of baking. When we have a reaction, when we're baking, the baking itself would be your reaction. The inputs, like if you're going to make a chocolate cake, your inputs are going to be things like flour, sugar, cocoa powder, baking soda, baking powder, sugar, eggs, all that good stuff you need when you are baking. You put all of those things together, you put it in the oven. That's kind of like your reaction. You take it out, you have a cake. It's not exactly the same, but it is something similar. You have these inputs, you have all of these ingredients that you're putting together to create something new. Same type of thing happens with the reaction. You start out with the chemical reaction. You start out with something, that something gets broken down and made into something new. Now we need to talk about some of the elements that we are going to talk about. Remember, elements are kind of like a bunch of those Legos together, or the atoms that we're going to talk about. I kind of use those words interchangeably. They're not, so I'm going to try my best not to use those words interchangeably. But the atoms and elements that we are going to be talking about during this unit are carbon, oxygen, and hydrogen. So when you see a C, that equals carbon. When you see an O, that equals oxygen, and when you see an H, that equals hydrogen. This is going to become important here in a second, because when you write chemical reactions, you don't write out the entire word carbon. You don't write out the entire word oxygen, you just write out the first letter or the chemical symbol for it, which is, in this case, carbon is C, oxygen is O, hydrogen is H, so it's pretty easy to remember and understand. I would write these down though, just as a quick reference guide. As you go throughout this unit, you probably won't need it anymore, but at the beginning, you'll probably need to reference back to it. So C equals carbon, O equals oxygen, H equals hydrogen. All right, so now we need to do some background knowledge on chemical equations, because this is also what we are going to be using during this unit. So if I were you, I would pause the video right now and write down this chemical equation. Don't worry about writing the arrows, anything like that. I would just write this C6, or excuse me, 6CO2 plus 6H2O, and then this arrow, don't worry about writing this red part, and then write C6H12O6 plus 6O2. So that's what I would write down. On pause the video, get that written down, because we're going to break it down here in a second. First thing that we are going to point out for this chemical equation is our atoms. So we have the C's, the O's, the H, the O, the C, the H, the O, and the O. So all of those things represent atoms. And again, we have our kind of key down here. C equals carbon. So this tells me that in this chemical equation, there's carbon, there's oxygen, there's hydrogen. Here's another oxygen, another carbon, another hydrogen, another oxygen, another oxygen. So we have carbons, oxygens, and hydrogens, and this is the order in which they go in. So that's the first thing that we're going to point out. Second thing that we're going to point out is these little numbers afterwards. So these little numbers afterwards are how many of that specific atom that we have, or that specific element that we have. So we have this little C here. There's no number after that. So that just shows me that there is one carbon. We have this O here with this little 2 after it, and that shows me that there is 2 oxygens. So in this little unit right here, we have 1 carbon and 2 oxygens. If we move over here, we have H2O, which shows me that there are 2 H's, which would mean there are 2 hydrogens. And then we have this O here with no number after that, so that would just be 1 oxygen. So we have H2O, and some of you probably recognize that H2O as water. Then we move over here, we have this long one, C6H12O6. So we have this C here, and then we have the 6 afterwards, which would show me that this molecule will contain 6 carbons. We have the H here, and then the little 12 after that, so we have 12 hydrogens. We have the O here, and the little 6 after that, so we have 6 oxygens. And then our last one, we have O2, which would mean that there are 2 oxygens. So that little circle here is going to represent the number of atoms that we have. Now we need to talk about the molecules. So I have put in a little square where the molecules are. So we have this entire little section right here is a molecule. So we have CO2, which is a carbon molecule. Or sorry, excuse me, carbon dioxide. So CO2 is our carbon dioxide. We have C, 1 carbon, O2, 2 oxygens. That makes our carbon dioxide molecule. Over here we have H2O, so we have our water molecule. We have 2 H's because it's little 2 after the H, so H2O, there's no number after the O, so it's just 1 oxygen. If we move on this side of the equation, we have C6H12O6. This is going to be our glucose molecule. So we have C6, so we have a little C here. We know that there's 6 of them because of this little 6 that comes afterward. We have the H here, we have this little 12 that comes after it, which means there are 12 H's, and then we have this O here. There is a little 6 after it, which means we have 6 oxygens. Lastly, we move to our last molecule, which is O2. This would be our oxygen molecule. It's a little bit confusing because the oxygen is the name of the atom as well as the name of the molecule. I apologize for that. And for that being so confusing, but we have this O here, we have 2 of them, so that means we have 2 oxygens in this oxygen molecule. This is kind of like an overview of these. You will take a quiz after that, so hopefully in taking that quiz you will understand what you do know and what you don't know about this. And then the last slide I have for you is breaking down these numbers in front. All right, and the last part of our chemical equation that we are going to talk about is this number out front. So we know that this molecule is carbon dioxide, but then we have a 6 in front of it. So this 6 in front of it is going to mean that there are 6 carbon dioxide molecules in this chemical equation. So we have 6 carbon dioxide molecules. Over here we have a little 6 in front of our H2O. We know that this H2O is water. So this would mean that we have 6 water molecules in this chemical equation. If we move to the other side of the equation, there is no number in front of this C6H12O6, which just means it's 1. When we are looking at these chemical equations, if there's no number in the front of it or afterwards, it just means 1. So we have C6H12O6, so that is glucose, which means there's only 1 glucose molecule on this side of the equation. And then when we look at this other one, this 6O2, O2 is our oxygen molecule, so remember there are going to be 6 of these oxygen molecules in this equation. All right, so let's talk next steps. So you're going to go to Canvas. You are going to complete the practice assignment on Canvas. It'll be over what we just talked about. What is a molecule? What is an atom? What is an element? How to read these chemical equations. And then you need to start on the next set of notes. So you are going to have to get 100% on this. They are multiple choice questions. If you are not scoring 100% and you are just very, very confused, I suggest going back and watching the video again. So you went through, you took notes on it. So now maybe just go back and just listen. Don't worry about writing anything down. Don't worry about writing notes. Just listen so that you can try and understand a little bit more, and then try the practice assignment again. If you're someone who's if you are trying to do this over and over and you are not getting it, that is what I would do.